So let's see how we would go about setting up the O-ring problem. First of all, let's draw a picture so we can see what we're doing. So I'm going to make an axis here, and we know that the outer diameter is 4 meters, so I'm going to let the origin be the center of the hole in the O-ring. So we would come out here 2 meters. Now we know that the thickness is 8 millimeters. So we've got to decide, are we going to convert everything to meters or everything to milliliters? So that's the first thing to do. So I decided I'm going to go to millimeters. So I'm going to make this 2000, and then it has this little thickness, and I'm going to spread it out just so it's not squashed to see my picture, even though it should be really close to here. I'm going to move it out this way. And this is going to be 8 here for this distance because it's 8 thick, and so this is going to be at 1992. And then we are going to have this O-ring right here, this circle that we would basically then rotate around the y-axis to generate the O-ring. So let's see what we can do to express this, and actually in looking at this we see we have symmetry, so I'm just going to worry about this upper half and then I'm going to double it. So I want to express the equation for this upper half circle, so I'm going to put a little x here where the center is, and I can figure out that center, and I can actually figure out this point right here on the circle as well. That would be halfway between the 192 and 2000, so at 1996 and 4, because remember the diameter here is 8 millimeters, so the radius would be 4. So if I wanted to write the equation for that circle, that is going to be x minus 1996 squared plus y squared equals 4 squared. So remember, an equation of a circle, what this does is it shifts the center over to 1996, and the y value for the center is 0, so we don't have anything here, and then it equals the radius squared, and remember this radius then is 4. Now let's see what we can do to find this volume as we rotate this around, and I'm going to use the washer method to do it. So first of all, let's look at a representative slice, and with the washer method the slice is going to go like this. So I'm going to have a little thickness dy, so I know I'm going to need everything in terms of y, but let's see if we can visualize as we rotate this around what those would look like. Well, I first have this complete thing out to here, which is big R, essentially our outer radius. So then we would have a disk, and then we would need to subtract off this length right here. That's our little r. That would be the area of the hole, so that we make it a washer. So this is just an x value out to this piece of the circle, and this is an x value out to this piece. So what we need to do is express x in terms of y, so we're going to do that with our equation of our circle. So let's go ahead and solve this for x. So the first thing I'm going to do is move the y squared over, and then to solve it for x, I'm going to square root both sides, not forgetting the plus minus, and I'm going to move the 1996 over. Now what this is with the plus and minus is, because it's x as a function of y, if we use the plus we actually have this half of the circle right here, and if we use the minus we actually have this half. So we're just going to use the upper half, and so using the plus will give us this piece right here, which is my capital R at various slices, and then when I use the minus I will have this piece over here, which is my little r for various slices. So let's go ahead and set up the integral. So we're writing in terms of y, and we're just doing this upper half. I'm going to double it, so let's go ahead and put our 2 there. So we see the y would go from 0 up here to 4. And then we've got pi big R squared minus pi little r squared. So we'll put the pi out in front. So we need this big radius squared. Well, that was 1996 plus the square root of 16 minus y squared. And that would need to be squared. Minus, now we need this radius of the hole, and that would be when I use the negative, because that would be this other piece of the circle. So that would be 1996 minus the square root of 16 minus y squared, and then that whole thing is dy. So there is my integral. It involves some algebra to square this and to square this, but then you'll pleasantly find that a lot of the stuff cancels out. So I'm going to leave that to you to do the algebra. But then bottom line, we get it down to not too hard to integral, but we'll need to use trig substitution. So essentially what's going to happen is we have our 2 that was out in front and our pi that was out in front. And we also end up with 4 times 1996, and we can move it out in front. And then we have left just 16 minus y squared dy. So do all this algebra and you should end up with this. And then once you end up with that, then you should be able to use trig substitution to evaluate this, and you should be able to find this volume.